everybody, welcome back to the workshop. So today we are going to be working on a air-powered rivet setter. Thanks for watching. Okay, getting into this real quick, I'm going to show you how we're going to make this rivet setter. Now, as you all know, I've already done a hand rivet setter before, and I showed you how to take and make a ball punch and how to make that ball punch go into a particular piece of stock to create a depression in order to make this depression here, so this way you can do domed head rivets. I've also shown how you can take and make a rivet block. Now, using the same domed head stuff. I am not showing today how to take and make this particular portion, the ball head. If you want to see that video, you can go to the link in the description and it will take you to that whole riveting series. Or you can go and actually search on the channel for my rivet series, which this will be a part of, and you'll be able to find how to take and make those tools. So what we're doing today is we're making a rivet setter that is pneumatic powered or air powered using factory bought tools that you can buy at most all hardware stores or mechanic shops or things like that. We are going to be modifying one of these today, most likely this one here, because I have found this one to be the least handy. I'm going to go ahead and cut this off, and I'm going to drill a hole in this piece here. When that hole is drilled, I will weld this in, insert the bit in there, and then weld around to keep it held tightly to it after we have done the forging here. So I'm going to show you very quickly how to do all this, just so this way you know, and you know, it really is very easy. It's just that simple. As you can see, that's going to add quite a bit of mass out there to the end, but that's okay because we just don't want the heat to travel up the shank and get into the air tool itself. We want that mass to be isolated here. If this gets warmed up, that's fine. It'll exhaust all that heat and it shouldn't radiate up the shaft as much. Now, we are welding a high carbon tool steel like this to a lower mild steel blank, or you can cut yourself a piece of spring steel or whatever. You can cut a higher carbon piece of steel if you want for your rivet setter. If you want to do a lot of rivets, I suggest that, maybe a piece of 1095, something like that, but we are going to be welding it. In welding these things together, it takes a very special treatment. You just want to take and make sure that you normalize everything, or that you anneal it a couple times, and that you harden and temper appropriately. That way you don't have a hard, fast line between weld differences in temperature, obviously, okay? So you want to be able to preheat these first, get these preheated, put them together, and then put them on a weld, and then go ahead and do a couple little normalization cycles. So this way you don't snap a tool while in use. Okay? So with that being kept in mind, that's really the only trick to this right here. So we're going to go ahead and get started at making these. I will go ahead and do the forging on this little bit here first, and I'll show you how that goes. And then once the forging's done, we will get this drilled out and get it welded up, and we'll see how she works. Okay everyone, just like in previous videos, how I heated this end up and I used a ball punch to take and punch that down into there, that's what we're going to do on this video as well. Now you can see a remnants again of the little end that I've already taken the value of cutting it off. I'm going to save this piece. You never know when it comes back in handy again. I save good tool steel like that all the time, little offcuts and whatnots. But we're going to bring out this piece that's hot, that's up to temp, and we're going to throw it in the vise here. We're just going to go ahead and lock this in the vise. Hopefully it'll hold it to some degree. Give it a good lockdown. And we're just going to go to town to adding this, hopefully in the center is what we're looking for. Got my center dot started, and I will have to probably take this opportunity to go to a little better gripping system here to take and add that center dot. But essentially you're just going to do this again and again, same way, and we're just going to keep working in that little center dot. Now, like I said, I've already went over this all the way through on how you do it with my a few months ago with this type of rivet tool, so I'm not going to make you see the whole process here. Once again, we want to see how this thing works at the end of the video. So let's get to that. I'll go ahead and keep forging on this, and it's essentially just wash, rinse, repeat until you get a good depression in there. Okay, now that we've gotten that depression in there, we're just going to address a little bit of this swelling up. Try to help center stuff up. And then we're going to end up coming right back to this. Okay? We're just going to end up coming right back to this and reforging that divot a little more. Just trying to keep this tool centered up the best we can. We've already gotten a little off track with this here. That's okay. But one of the next things we'll do is we'll come in here, and I might get another heat on this to do this, but we're going to go ahead and dome these edges away from that center part. We want it to, not a lot. Actually, I got enough heat in it to just do it now, so I'll just do it like this. Just enough to give where that's setting the rivet down some relief. And we've got to forge down those areas a little bit. As you can see, it's starting to get kind of whopper-jawed a little bit, but that's okay. What we're going to do now that that has a little bit of crown, we'll come back in there and we'll straighten this out with this rivet set tool again and try to get that depression a little crisper, and then redress this once again just a little bit. The main thing that you want to worry about is just keep the whole tool centered up. It doesn't take a lot of heat or forging energy to do this, but if it's a little offset, you're always going to be driving your rivets at a weird angle. So you want to make sure it's as center lined as you can in the tool, so this way when you start driving a rivet, it goes straight down and not off to one side. Start concocting off to one side. So again, I'll go ahead and finish dressing this out. I'll do that last little bit, and we'll just move on to the actual shank portion, which is the fun portion of this video. I've already taken the temper out of the end of this to make it a little better, and so we'll let that cool down, and we'll drill a hole so that can be put in there like so, and weld it up. And then we'll be ready to start making rivets. Okay, everybody, here's what we have so far. So I went ahead and finished doing that last little heat, and I also did a little grinding, like cleanup work to this depression here. Now you can see that it fits a rivet head very nicely and securely. That's what we're wanting. So you always want to go a little deeper than what you anticipate, because if you don't, what'll end up happening is as you clean up this face, you'll have more rivet head here. You want these two to essentially sit flush. When this rivet's fully driven in, you want them to sit almost flush. It's okay if there's just a little bit of this rivet head still sticking out, but be aware that that can cause a little double cut line or a little bit of run out. So you want to be careful of that. So what I've done is I went ahead and drilled a hole, and in this particular case, it's apparently a 29/64 is the correct drill bit for this size shank air tools. I do not know if this is the common size all the way across the board, but with the air tools that I have, it seems to be the case. So just drill a hole for the size that you have. Now, there's many ways that you can come to that conclusion. You can use one of these. Somebody called these a veneer caliper. You can check that out and you know, look that up. As far as that goes, I'll put a link to this one in the description below to find the actual thickness of the piece. Or you can actually use a little drill gauge like this. These come in metal versions and plastic versions like what you see that I got here. And you can just slide it through one that it fits without any slop. So those are your two options on that. So now the last thing, I won't be showing the welding on camera just because I don't want to ruin my sensor. I need to get a way of being able to show the welding, but that'll come in time. I'm a bit tapped on finances for the moment for further YouTube iterations or upgrades. So I'm not going to show that, but essentially just run a nice clean bead weld all the way around here. You want it to be substantial enough because it's going to take some force. And then the last bit that we'll do is we'll actually chuck this whole thing in the fire and get it nice and warmed up while trying to keep this end cool to preserve the temper that's in this portion of the tool. And that should relax it a little bit to where we do not have any sort of severe contrast difference between the weld and the high carbon steel, which will be a brake line. So I'll get this welded up. Then we'll be over at the forge, we'll get that heated up, we'll let it cool, and then this tool here will be done. Probably the last thing that I'll do after this, while this is cooling, I will actually quench this in some water just to give it a little bit of a toughening up. It's not going to do much as this is just mild steel, but I feel that it gives it just a little tougher finish to it. After being in the forge, a little more surface abrasion resistant, and it should last, well, it'll outlast me. I'm not doing anything where I need, you know, 5,000 rivets or anything like that to do. So once again, if you're doing this in tool steel, you'll want to go ahead and harden and temper these properly. With that being said, this is an unknown steel to me. I do not know what this is, so it would be best for you to go to your local scrapyard. They usually have a little laser gun that they could tell you exactly what this material is, and I would highly suggest that, finding out what these are made of. Obviously, if you forged this all as one piece by yourself and turned it out of a known steel, then you know how to properly harden and heat treat the tool. This is just a quick way of making a rivet setter, and this, once again, is being used with really hot rivets. This isn't cold rivets. I'm putting hot rivets in a cold tool. And so as long as I keep this end cool, there will be very minimal deformation, even though it being mild steel. So without further ado, let's get this welded up and get over to the forge and do this final little step of cooling it, so this way we can get to using it. We've got it good and welded, and you guys will see the final result of that when we actually go to use it. I put a pretty good heavy bead around it, and now what we have is we actually have the end of this sitting down in the fire, trying to warm this whole piece up right around that weld. We're not trying to go up to critical temperature. All we're trying to do is essentially remove any sort of hardness or brittleness that may be in this tool. So I'm not trying to go up to super critical or anything else like that. We're just wanting it to have a little bit of a softer temper to it. We don't want it to be hard, okay? So now, to protect the temper and the rest of the tool, I'm going to set a wet rag on it right here. You already see that it kind of started to sizzle a little bit. So it's definitely getting hot enough where it was about to wreck the temper in the rest of the tool, or the hardness, and we don't want it to do that. So we want to keep that whole collar area cooled off. And you may ask yourself, well, why for that? Well, if that area gets soft, think about it. There's a hammer hammering on this end at about 3,000 beats per minute. If this doesn't maintain its structural integrity, what you're going to end up having is that'll mushroom out inside your air tool. So that's not what we're wanting. And obviously you can see I've got another bar here heating. That's for another video. I won't talk too much about that, but oftentimes when I have a job like this that I'm doing, I put two things in at once if I've got a fire going here. The ideal of this is to let this come up slowly and to take and reduce stress on one tool. So I'll let that continue to do its thing, keeping it cooled off on this end of the firebox, and then the rest of the tool will get nice and hot and soft, and I can continue to do some forging in the meanwhile. And so this is a very handy way of doing this whole setup. So that's it for that. Next part, I'll bring it out and I'll give it a little bit of a quench, and then I'll let the rest of the tool just air cool. And we'll come out. That joint is good and relaxed now. That's what we're wanting. We want to keep it that way. And now all I'm going to do is just give this a little bit of a quench on the end of this. Not enough to create a severe line up top. But again, we're just trying to take and toughen up that end just a little bit. You can believe what you will about that. Mild steel does have just a bit of carbon, not anything notable to create a very hard anything, but it has just enough in it that it can toughen just slightly if you do it in water like this. So now, what we'll do is we'll just let this tool rest and let it cool itself down. And probably what I'll do is I'll fill a little can full of water and just put this shank right there in that water so it doesn't, temper too much. But that right there is done. And so really all we're doing is relieving. Once again, we're just relieving. I know I've overstated this point, but I just want you to get it into your head what you're doing with the welding here. You are just wanting to relieve that really stressful line of intense heat where it welded that material to it and the rest of the hardened tool. So that's really all you're doing. And as long as you got that concept, you'll be alright. And here we are, ladies and gentlemen. Let's do this last little part. So I'm going to give you a quick second. So here's one of the tools. Like I said, links in the description, and it'll be at the end cards at the end of this video of where I've already made this little bit of a bolster plate here for rivets. And all we're going to do is we're going to get a torch. We're going to heat this end up. We're going to stick the rivet head down in the correct rivet block for its size, like so. And then we're going to take this top tool that we have made, we're going to put it right on top, and we're going to see how this puppy functions. My guess, it's going to function really, really well. So let's go ahead and get it good and hot. We're going to rivet her on down, and then that'll be the end of this video. So I'll go ahead and just say it now. Thank you all for watching this video. I hope you all enjoyed it. If you liked it, give it a thumbs up. If you disliked it, give it a thumbs down. Like always, leave me your feedback in the comment section down below. I enjoy reading most of everybody's comments. So just let me know, once again, other tools and videos that you'd like me to do on this air tooling, and I'll see what I can do. So without further ado, let's get to the last part and finish up this video. Enjoy.